Right. Good evening. I'm here to talk about a shell that I'm building. I'm advertising as an expressive, versatile, cross-platform shell, and it's also implementing Go. My name is Chi, and just a little bit about myself. I'm a software engineer at Google, but this talk is not related to my work. I don't speak for my employer, etc. Standard disclaimer stuff. And this project was started in 2013, which I just realized was the same year this meetup started. I should have put something more there. Didn't realize that, even though the name is literally called 10-year anniversary. I'll try better next time. Okay, so let me start by saying why I thought it was a good idea to build a shell. It was kind of obvious because I used the shell every day when I used a computer. And back then, the choices were bash, zesh, and fish, I think. I just felt the traditional shells were not enough. Like the UI is arcane, and the programming language is even more arcane than the UI. So I wanted a shell with nice interactive features, but also, kind of more importantly, some serious programming capabilities. And also, let me get this out of the way, why not to build a shell? There are many arguments, but I think these two are the most common. The first one is, it's just too hard for existing users to switch, which I think is very true. But I also think it's hopefully overcomable because if you have something radically better, then probably people will switch. But another kind of argument is sometimes people just say, like, shells are just supposed to be bad. They're supposed to be primitive, arcane, which I think is just defeatism, and I would not try to argue with defeatism. But I will call upon my defeatist friend every now and then to just make my points. All right, so this talk has two parts. First, I will talk about Elvish as a shell and a programming language. The second part will be about my experience of building Elvish in Go. We don't have a lot of time, so obviously I cannot teach all of you how to use every feature of Elvish. So this is more of a case study or like showcase as this was introduced. All right, so let's start with the demo. And I have my terminal open here. Let's say that I'm ready to write some new Elvish code, right? And the first thing I would do is to go to the directory where I kept the source code. Normally, you would just start by typing cd and stuff. But Elvish has a location mode, which you trigger by Control-L. It's kind of analogous with the browser's location bar. And we already see Elvish is actually the top directory because I'm here all the time. And before I go there, I want to direct your attention to the scroll bar to the right. I'm very surprised. This is something that no other project has picked up, but yay, there's a scroll bar, like it's finally 1980 again. And okay, now I'm here. Now, of course, I know the layout of the Elvish source tree, but let's pretend I'm new. So I want to kind of explore the source tree a little bit. There's this thing called navigation mode, Control-N, and it will allow you to just look at the files. There are previews. You can go to a directory. You can go up again and do stuff. And if you want to do something to the file, like if you just, let's say I want to edit this file, I just type in and press enter. It inserts the file name. All right, so this is part of the demo. And the next part, I will do some real shell scripting. Let's say I want to know how many lines of code there is in Elvish. And I will do this using this. First, I would do cat start.go that concatenates all the Go source files. But I'm not interested in empty lines. So I will filter out empty lines. And then I use wc-l to count how many lines. So there are 60,000 lines of code. So I want to spend a little bit of time looking at this code because this actually kind of shows how Elvish is still kind of a shell because there's actually a lot of things to unpack here. So first you look at cat, grep, wc, which are conveniently highlighted in green here. These are all actually external commands. So this is something that's kind of, I think, a hallmark feature of shells because if you were to write this in Python, you will start by saying something like start process like new call like something something and then quote cat. It wouldn't just say like, cat, or any other language. Like Python is the only one I can recall. Right, but in Go you would say something like os.start process, something like that, and probably also look path first. So this is really a hallmark feature of shells. And there is wildcards. This is like slightly non-traditional because it's a recursive wildcard. It finds all the files in the subdirectories, but that's kind of still kind of shell-like. Another thing that's worth remarking is all of these arguments, like these are actually strings. Like if you were writing in a different language, you would be passing strings to grep to WC. But in Elvish, you just write them without quotes. This is called bare words. It just means you don't have to quote things that doesn't have special characters. And finally, the entire thing is a pipeline. And one thing kind of remarkable about pipelines is that it's inherently concurrent. So all of these commands are actually running at the same time, and their inputs, outputs are connected using pipes. All right, so that's kind of the traditional angle of Elvish, but there are things that are kind of somewhat new. So the first thing is we use, the command output is like expanded using just parentheses. But I really want to show this just to show you how easy it is to get an Elvish binary. So goenv go OS is the operating system. Goenv Arch is the CPU architecture. And here I just downloaded a latest Elvish binary build. Now if I just change mode, I get Elvish binary running, thanks to like cross compilation. Another thing is variables must be declared so that the next time you have a typo, it actually tells you have a typo. And because I'm in this interactive session, this already tells me like lore me does not exist. Another thing is Elvish does not split your variables. So if I were to do something like this, say in bash, if I do touch $x where x has spaces in them, this will actually create two files. Elvish just doesn't do that. Like whenever you have a variable, it's one thing. Like this is why in traditional shells, you will be seeing quotes everywhere. Every time you use a variable, you need to quote it just in case it contains like spaces. This just is not a thing in Elvish. All right, now to some radically new stuff. Data structures, which is radically new for shells, but not really if you're talking about any other programming language, right? So this is really just kind of sensible programming language stuff. So you can write lists, this use square brackets. You can write maps, which also use square brackets because there's a severe shortage of punctuations. And but in maps, you write this like, it looks like URL query parameters. And you can index them, which hopefully is kind of not foreign if you have used any non-shell language. You can index your list with the index, your map with a key. You can also nest them, which is kind of new for shell, I guess. So this is a list of a list, and then a list of, and then a map. And kind of somewhat unusual is Elvish allows you to use the list as a map key. So look, this one is a little bit hard to read because both lists and indexing use square brackets. But here we're actually using a list as a key to index. All right, now I will call upon my defeatist friend who tells me that you don't need data structures in like shells. And I have two examples. I actually have more. I had to cut them out to like make the talk in like fit in half an hour. So one thing is what I would call something like casual scripting stuff. Like here's an example. Like let's say you want to deploy like Elvish to multiple SSH servers. If you have one, you would just call SCP. If you have two, you will write a for loop, right, in a traditional shell. But what if the problem is just slightly more complex? Like if you have two SSH servers that have different SSH ports because somebody preferred to set it up this way. Like in a traditional shell, at this point, you'll probably be thinking about like, how do I encode that? How do I encode the name and the port together? And then how do I take it apart in a for loop? You probably have given up at this point. But because you have data structures, like I would say this problem just lends it very well to like data structures. You just define a list of 2 maps. Each map describes the host. It has a name, has a port, and then you do this for loop. And my defeatist friend would probably just say, like, at this point, you should use Python. But I don't want to rewrite like my beautiful SCP command to like a sub-process.call SCP. Like, why would I bother with that? I might as well just do something manual. So I would say having access to actual data structures make this sort of kind of casual scripting automation thing like much, much easier. Another thing is APIs in the shell. So for instance, Elvish has this feature called abbreviations. I'll just do a demo for this. So the idea is whenever you type something, you will expand to something else. So if I do this, and then I type x, it expands to this. So this is something, in Elvish, this API is just a map. It's a map from the thing before expansion to the thing after expansion. Like in a more traditional shell, you probably will be looking at like a certain command to configure abbreviations. And you need to learn like how to add abbreviation, how to delete abbreviation, how to print all the abbreviation. But in Elvish, because it's just a map, if you want to print it, you just print the map. Like preprint is just a general pretty printing thing. All right, so I think these are good examples of better programming language leading to better shell. And then I'm going to surprise you with something even more radical, which is lambdas. Elvish has lambdas, which are like anonymous functions. And the syntax uses curly braces. And if you have arguments, you put it like between pipes. And if you don't have arguments, you can also omit the argument list. And you can call the lambda. Because if you define a lambda, what you want to do is to call them. And let my defeatist friend ask me again, like, why do we need lambdas in shells? So one, I think, kind of very obvious example is that if you are customizing your prompt is actually a lambda. So for instance, the default Elvish prompt does not have your username. If you want your username there, you just write a lambda, and you know how to get your username, use the whoami command, and you just add that to part of your prompt. And again, I'm going to compare this with the more traditional shell where they have this mini language, like you need to know like \u is the username, \w is the working directory, which is all very concise and like terse, but you have to learn a new mini language, right? And if you want to do anything more complex, you need to know how to like execute commands inside PS1, like leading to things like quoting health and stuff. But in Elvish, because it's a lambda, like I think this is a very simple API. And also command completion in Elvish also has a very simple API. It's a map from the command name you want to complete to a lambda that outputs the candidates. So let's say I have this beautiful full command that I want to configure a completer for. So I would just assign a new element to the arg completer list. And let's not worry about what the argument is doing. And let's just write out 2 things, like Lauren and Ibsen. After do this, if I type foo and then I press tab, like these are your candidates. Like, in Elvish, this is all there is to the command completion API. There is no separate like add completion, like del completion, list completion. There are no separate such commands. You just need to know that this map variable exists. And if I want to see which commands have completions, like I just print the map. Like these lambdas are not very printable, but at least you can see the keys. All right, and finally, these values like lists, maps, and lambdas, they're actually more types. They can also participate in outputs and pipes. And this leads to some interesting consequences. Like because we use parentheses for output capturing, arithmetic looks like Lisp, if you know Lisp. Some people love that, some people hate that. And there are also a lot of string processing functions that outputs a string as a value instead of as just bytes. This means that you don't have to worry about things like what if the string contains new lines, spaces, or even like embedded null bytes. They just don't matter. You just don't need to worry about those. Like this is a real command I found in my history where some weeks ago I need to convert a bunch of JPG files to PNG files. I know there's a very short syntax in like bash where you can trim the suffix, but I can just never remember that. If it's just a command, that's kind of much more intuitive for me. And there are also a lot of built-in string processing functions. You can count the number of values going via the pipes. You can do something to each of them. We don't have a lot of time to go into those. All right, so that leads to my conclusion of the first part. So I would say Elvish is kind of still a familiar shell if you have used any shell before, but it has a real programming language. And I think the real programming language leads to the Elvish being a better shell. And there are many features I didn't have time to cover, but those are kind of your standard programming language features, but in a shell. All right, so the second part is Elvish as a Go project. Let me start by giving kind of a very high-level overview of how the implementation works. So whenever you're talking about a programming language, there's this classical divide of like front-end and back-end. The front-end is the parser. It takes your source tree, it takes your source file and turns that into a source tree because the source tree is much easier to work with just a bunch of bytes. And there's the back-end, which then takes the result of the parser and actually executes that. And Elvish has a handwritten parser, which means that it doesn't use like things like parser generators. And because I'm trying to tell you about this in 1 minute, the two words I summarized its implementation, it's just interface and recursion. So let's look at one of the things. Like for instance, in Elvish, the top level node type is called a chunk. A chunk is just a bunch of pipelines that could be separated by new lines or semicolons. And so I have this chunk type, and it has this parse method. Something slightly counterintuitive is that the parse method, what it does is it actually starts with an empty chunk node with no content in it. And what it does is actually it populates the content of the chunk node. So the overall structure of this is actually quite simple. It's a for loop. And whenever you can still parse a pipeline, it like creates an empty pipeline node. And then it parses this pipeline node. And then it adds that to itself. Like this is really all there is. And then this goes into a recursion, like pipeline has its own subnodes and so on and so on. And all of those nodes implements the same interface, which is just this unexported parse method that takes a parser, which keeps the track of the current state of the parser. This is really all there is. You need to know to write a parser, really. It's just interface and recursion. And the backend is kind of similar. It's also interface and recursion. So there are many different ways to implement a interpreter. The way Elvish implements this, I think is slightly unusual. I haven't seen a lot of other languages do this. It's also not very performant. What it does is it compiles the parse tree that we just saw into an operation tree. And the operation tree also works via interface and recursion. So for instance, the chunk op is the operation that a chunk node is compiled into. So you can see it has a lot of sub-ops, which is just all the ops the pipelines compiled into. And what it does is like it just iterates through all the sub-ops and executes them one by one And Elvish has exceptions, by the way. So if there's anyone throws an exception, it just like returns immediately. And so on until you reach the simplest type of the op tree. And again, there's this interface. It's called an effect op. And then it has an exec method frame, captures the current runtime state and returns an exception. And terminal UI is an interesting topic, but it's at the end of the day, like Elvish doesn't use existing like terminal UI libraries. I wrote one myself. At the end of the day, what you need to know is a lot of arcane escape codes, because terminal UI is mostly just text-oriented. Like whenever you type, you press a key, like an up or down key, it's just internally turned into a bunch of like bytes, just like special escape sequences. The same for outputting, like you want to change the color, you want to move the cursor, those are all just special escape codes. All right, that's the overall structure. And then I guess I will talk about some interesting uses of Go features that you may or may not expect in a shell. So the biggest thing is running external commands. That's the top thing a shell does. That's just the os.start process. I was a little bit surprised by this because I thought like the standard API wouldn't give enough control for a shell, but it's actually sufficient. Like you can control everything like file descriptors, environment variables. It also has this like SYS field where you can plug in like system-specific configs. So that's pretty nice. Pipelines. Pipelines are inherently concurrent. So Go routines is a very good fit for pipelines. And another thing is a pipeline only finishes when all the commands finish. So that's just sync.wait group. And as I said before, all the different values can participate in outputs and also pipes. That's just a channel. And Elvish also has big numbers, which is useful if you want to find out what's the value of 2 raised to 10,000, I guess. So it's not very readable. So that's just math/big. And Elvish also uses a lot of Go standard library to provide Elvish's standard library. Like the str::trim suffix I've shown before, it's just Go's strings.trim suffix. There's a kind of a hacky reflection-based binding system. So why write a shell in Go? So the first reason is Go is reasonably performant. If you write a shell in Python, it's going to be even slower than Python, kind of almost by definition. So I need a somewhat performant language, and Go is like definitely performant enough for your shell. And Go has a suitable runtime, like Go routines I mentioned before, because there's actually a lot of concurrency in a shell. Garbage collection might be surprising, because you probably think of garbage collection as a downside when you choose a language, as kind of a necessary evil to not manage memory manually. But for Elvish, it's actually an upside, because Elvish is also a garbage collected language. So because Elvish values are Go values, unreachable Elvish values are just unreachable Go values. So I can just use Go as garbage collector. If I write Elvish in Rust, I would have to write my own garbage collector, which is not something I want to spend time doing. And also fast compilation, that's great. That's really great for short development cycles, and easy cross compilation. So I can have like one binary builder that builds pre-built binaries for every platform Elvish supports. And also back in 2013, Rust wasn't released yet. So I wouldn't choose Rust today, but I also wouldn't choose Rust in 2013 because I couldn't. There are some things that came up that I wish Go is better though. Nil safety is one thing I think a lot of people have probably encountered. There are just too many crashing bugs where I just forgot to check if this is nil or not. Plugin support. Plugin is a way for building dynamic libraries in Go. The reason I want plugin support is because Elvish's binary is huge. I wish to be able to split out part of that into dynamic libraries so that the main binary is a little bit smaller. Unfortunately, plugins are only supported on Linux and Darwin. but Elvish supports more operating systems. And also a faster reflection, because we have this reflection-based binding system. Like today in Elvish, calling an empty Go function via reflection is much, much slower than calling an empty Elvish lambda, which says something because the overhead of lambdas are also very huge. I didn't really optimize it. All right, so Elvish was started in 2013. Back then, Go 1.1 was the latest version when I started. But kind of surprisingly, but also unsurprisingly, there are relatively few changes that are like really impactful over the years. The two biggest ones are the two earliest ones. I think anyone who used used Go before 1.5 knew that like 1.5 gave us rendering, 1.11 shipped modules. So those changed how you manage dependencies. It didn't have a very large impact on the code itself, obviously, but I had to learn all those things. Trim path was interesting in 1.11. It was necessary for reproducible binaries, actually, because before this version, every time you build a Go binary, it actually embeds the absolute path of your code. And that just kind of defeats reproducible binary building, because you have to make sure you are always in the same place on each of your builder. Trim path made that unnecessary. Go embed, part of Elvish's standard library is implementing Elvish itself. Before Go embed, I was just writing those modules inside like enormous Go constants. Go embed made that a little bit nicer. I can actually write them in Elvish source files and just embed them. Generics was surprisingly not impactful for Elvish, because Elvish was actually not very generic heavy. It has data structures, but all those data structures are just like any, everywhere, because Elvish is a dynamic language. I rewrote like maybe 200 lines of code using generics, which made it much cleaner, but like, that was that. Fuzzing was also interesting. I used fuzzing to discover a bug in the parser, where for some pathological inputs, the parser would take exponential time. It would take 2 to the n time. So the fuzzer was really good at discovering those kind of very bad performance issues. Elvish uses continuous integration, and the code is on GitHub, so I use GitHub Actions. I think this kind of standard GitHub Action, like Go stuff, like running tests, Go vet, static check, and it also uploads test coverages to codecuff.io, which is, the test coverage is currently like 92, by the way. I'm pretty proud of that. And I also use Series CI because it has support for more platforms. Elvish supports the 3 major BSD flavors, and Series CI, it doesn't support that directly, but allows you to use any GCP VM image, and there are GCP VM images for all the BSD flavors. And it also has ARM64 runners, which GitHub Actions kind of surprisingly doesn't have. And because it's an open source project, it doesn't use that much resources. Both are free for my use cases. Elvish also has a website that is actually updated on every Git push. And I use GitHub's webhook for that. Webhook is just something, whenever you push something, it will make a HTTP request to your nominated endpoints. And I reinvented a lot of wheels in like how to build the website. I wrote a custom static site generator. I wrote my own common mark implementation, actually. So these were all like things I built on my own. Like, also, this slide deck is also uses my own common mark implementation, because I found that to be the easiest way to get Elvish highlighting. Like all the other frameworks are just kind of too tedious. And building the binaries, they also build the binaries. It's actually like one of the website pages has all those, there's a table of all the pre-built binaries. And they're reproducible thanks to trim path. And I actually make sure they are reproducible. I have builders in CI environments that what they do is they also rebuild the binaries, and they pull the binaries on the website to make sure they're actually like byte to byte identical. And all of this is actually has 2 nodes globally, and there's a geographical DNS. So I'm kind of invented a tiny I CDN myself. So all the infrastructure, like it's parallel in those. There are 2 webhooks, 2 like builders, and VPS, domain name, DNS. This combined like cost me about $20 per month, which is not that much. All right, that's the end of the talk. If you're interested, go to the website, which is just elv.sh without the I. And there are user groups and a lot of other links you can find on the website.
Thank you so much. If you're all right, we could maybe let's see if there's any questions.
Oh, yes. Sure.
Yeah. So does anyone have any questions for Xi? I do, because I'll go first.
Wait,
So,
hang on.
oh, we want to record questions. Okay. You're just going to walk around like a creep?
Basically,
Yeah.
yeah.
Sure. Thank you very much for that.
Okay, I'm ready. All right.
I was ready. Okay, so yeah, I was going to ask. It runs in. That runs in any terminal, does it?
Yes.
And I noticed that you say it was standard in and standard out is really the interface that you have.
Yeah.
Some things were right aligned. So how do you know where to write that?
That's part of the kind of arcane escape codes thing that's in the terminal. Well, actually, not really. So you can query like you can query the terminal with, but that's actually a system call. That's not the escape code thing. So there are APIs where you can get the width of the terminal.
It's a syscall to
Yeah.
get that. Amazing. Okay, do we have any other questions? I think Ben's put them off by saying he's going to go record. Okay, Ben, come on, he's got a question.
I can't even see you.
It's like proper press thing, isn't it?
Just curious. So, if I wanted to just pick this up, I'm curious. Can I just use it straight away? And I noticed right at the beginning you said you had like Control L brings up locator mode, but I'm used to like pressing Control L to clear the screen.
Mm-hmm.
So, are there things I'm going to come across as I use it that is like, whoa, what was that? I didn't expect that.
Yeah, there's this built-in module called readline binding that kind of mimics the more familiar key bindings. Like if you do this, Control L is actually clearing the terminal, and that rebinds Alt L to the location mode. Right.
Cool. And one more interesting question. I'm curious, do you own this or does Google own this?
I own this because there's some company policy exemption stuff that I applied for.
Thank you. Good questions. Okay, unfortunately that's all we've got time for, but thank you so much for Xi. Thank you.